down to my starting recording, and now the video is going to start with me halfway through a sentence, so that's always a good start. Good times. And now Sophie's on the video. Good. Anybody else who just spoke? You want to be on the video? Jack's getting himself on the video. It's good. Brad's on the video now. Thanks, Brad. Okay. Scatter plots, just to remind you, hopefully you know, a scatter plot is the name we give to a plot that represents bivariate data. Bivariate data starts with BI, which means 2. So it's that Latin prefix for 2. So when we talk about bivariate data, we have 2 variables. And we put them on a scatter plot because that's the best way to represent 2 connected variables. They might not be correlated, but they are connected. So if I wanted to just do a graph of everybody's height in this room, that's only one variable. That would be univariate data. We would use a bar chart or a pie chart maybe, or a stem and leaf plot. All those things we did in univariate data. Scatter plots represent bivariate data, so we might have people giving me their heights and their arm spans. And that would be a connected pair of variables, which I could represent on a scatter plot. That's what bivariate data is. Interpreting a scatter plot. And again, you will have seen this before. Lucas, please. Thanks. You will have seen this before, but maybe not in this much detail. So when we interpret a scatter plot, the assumption is that you've already drawn a scatter plot and you can see a series of dots like this. So we're looking at some dots on an XY plane. A scatter plot should usually only have one quadrant, so there should be nothing over here or down there. And we would still have our negatives here. Even if there were negative values, we'd have them just in the one quadrant. We should be looking at a series of dots. In this case, there doesn't look like there's any connection. And you can see that because the dots are just randomly spread around that quadrant. So there's nothing going on. We can't make any comment about if I change X. If I increase the value of X, Y increases or decreases. It doesn't say anything because we've got values everywhere. So this is a non-connected pair of variables. So there's no clear pattern. And the points are, as you can see here, randomly scattered. Now again, I've got that delay. So here's 3 examples to talk about. And each of these do have a clear pattern. Now I would hazard that they're not strong. So we'll have to talk about the strength of the correlation in a minute. But there's a clear pattern here. And again, A and C you will have seen before. B maybe not so much. A has a clear positive correlation. If I increase the value of X, generally speaking, Y will probably increase as well. I can see that that's got a line of best fit that sort of follows like a positive linear function. And you'll need to recall your work on linear functions for this topic. C, the third one, has a clear negative correlation. As X increases, Y decreases. So this could be something like the warmth of a cup of tea over time. So as time increases, the temperature of that cup of tea goes down. So we've got a negative correlation there. One goes up, the other goes down, the other goes up, one goes down, etc. This middle one here is a bit different. Now you might comment that this has no correlation, there's no clear connection between the variables, but I think the point they're making here is that you can see actually a little bit of a correlation like this. It's almost parabolic. And again, you don't have to know anything about parabolas, but you might talk about the fact that there is that curved correlation. And so this, because for those of you who do know anything about parabolic motion, you might be talking about throwing a ball. So this could just be a data collection for somebody who's thrown a ball across an oval. And the data is a bit scattered, but it kind of follows that curve that you'd expect a projectile to follow. So we've got that situation. So you're looking to, first of all, define if there's a clear pattern, and then you might define whether that pattern is linear or non-linear. So we're not so worried about whether it's parabolic or something else. Is it linear or non-linear, that pattern? That's the first thing. After we find a clear pattern, wait for the lag. If we find a clear pattern, we need to talk about the direction We need to talk about if there's any outliers associated, and then we need to talk about something called form, which is a little bit to do with strength. So there's some language in here, but what you'll find is as you practice this, it's a pretty procedural thing. So you just get your scatter plot and you go, is there a relationship or not? And then you start talking about, is it positive, is it negative, is it linear, is it non-linear? Are there outliers? Is it strong, is it weak, etc. So let's have a look at this. Direction, so this is straight out of your textbook, so you don't need to write this down necessarily. Two variables can have a positive or a negative association, or they might have no association. Now, the positive and negative only really suits a linear association, which is what you will do 95% of the time. Sometimes you'll do some stuff to do with non-linear, but mostly you'll do linear. So let's have a look at an example here, which I've forgotten to write the answers of, which is good. But here's 3 examples and answers. So in example A, I would hazard to say that this has a negative correlation, but it also looks like it's kind of dropping off at the end. So there's a bit of a non-linear shape to it, but there's not enough data that we can definitely say it's not just linear. So you can call it linear with a negative correlation or maybe non-linear. The second one here looks to me a little bit like it has no relationship. But again, you might hazard to say, well, that's an outlier and there's a bit of a constant relationship. And it maybe doesn't matter what the age is, generally you're somewhere between 5 and 15, and that just varies. But I would say there's not really a clear relationship, no association between age and diameter. And then the third one, which is height against height of mother against height of daughter, and you can see here there's a suggested positive relationship there. We'll get to this in a minute. This doesn't look very strong to me. Looks quite weak, but it's suggested that it's a positive relationship. So the direction of association is positive, and that leads us to the conclusion that taller mothers will have taller daughters. But again, as you'd probably expect, there's obviously that's only 50% of the story because you also get some of your DNA from your father. So that could change the situation, but there should be some loose correlation there. Let's talk quickly about the form. So the form is when we're talking about whether it's linear or non-linear. And again, like I say, mostly you're going to talk about linear, but there are non-linear cases that pop up. Your expectation on how in-depth you deal with non-linear cases is not massive. We expect you to be able to discuss them, but you're not really going to go into modelling them or building regression on them, and you can't talk about whether they're positive or negative. So there's a bit of an issue there. So you can see a couple of examples of linear situations, and then down here there's an example of a non-linear. That's curved, and you can see it kind of dropping off at the end. Again, no, and this comes down to the amount of data. You might argue the point here that that's kind of actually just linear with a couple of outliers. So you've also got to make sure you've got enough data, and that's something to consider in your PSMT when you get there. Is how much data have you got, and does that data provide you with enough evidence to definitely say that the association claims you're making are true? So you've got to be a bit considerate of that. So we've got form, and we've got direction. Are the first 2 things we have to talk about. And the third thing is the strength. Well, actually, let's talk about the form of these 2 examples. There you go. You can see 2 examples there. So this first one, I would be happy to argue that that is linear, and it goes through the scattering of points, but it's very weak. So again, you could put forward the argument that there's not really an association there, but there does seem to be a bit more of a bunch down there and a bit more of a bunch down there. And one way that you can view this is if you got about the centre and just popped a little cross in there. This is what some people do. If most of your data exists here and here, well, then you do have a positive correlation, and it's reasonable to say that. So another way just to do that visual test is to cross it off and see if it exists. Down here, I've got a non-linear relationship. Again, you might argue that it's a bit linear, but it does bend off a bit at the end to create a curve rather than a straight line. Any questions or not. I'm talking very anecdotally. We don't really get into the formula number-based maths until later in the class. Okay, last thing. Here's loads of scatter plots. So if you get a question like this in your exam, we're going to expect you to make reasonable judgments. So I would say that it's very reasonable that you're going to say strong, strong, strong. And this is, you can see here in the subtext, strong positive, strong negative. This is non-linear to me, but the other two are linear. So I would expect you to be saying this is a strong positive linear association, strong negative linear association. Strong positive association is positive the whole way, but it's also non-linear. And the stronger it is, the easier it is to make that decision about linear and non-linear. Down here, we're talking moderate. And you can see that again, it's spread out a little bit more. So it's not perfect, but there's a clear linear relationship here and here. And I think this one's doing its best to be a bit curved. But again, you can kind of see a relationship. So really you go, oh, can I see that if I increase this, something happens here? I can make that judgment. The high ones are only at this end. So it's a reasonable judgment to make, but it's not perfect like these guys are. So it's going to be moderate. The problem's usually down here. And this is where sometimes you might get questions where we take either answer. If you get down to here, you could probably argue this one or all of these have no association. But again, it's about recognizing that in this one here, for example, there's kind of this little corner here. It's going to be lag again, isn't it? There's kind of a little corner. It's going to pop up in the bottom left and the top right where no data exists. And because of that, and particularly if you have enough data, because of that, it kind of suggests that there is some sort of relationship, but it's really weak. I definitely wouldn't be confident making predictions from that data, but I can confidently say that there are patches of data missing, which means that there is some very weak relationship. Whereas if you go down here, I mean, there's a little bit missing there, but that exists. Over here, maybe at the top and around there, but again, there's definitely no relationship down there. But up here, you can have a slight relationship. Go through. I mean, it's a little bit hit and miss some of these, but you go through and you practice those skills, and you'll find that you're probably matching the answers most of the time. In summary, there though, strong should be really obvious. Moderate will be, oh look, I can see there's a relationship, but I'm not confident in it. That should be the feeling you get. Weak will be, I don't think there's a relationship, but I can see some missing parts in the graph. So I can see bits that are missing, which lead to kind of that straight line relationship. And then no association will be, there's dots everywhere. And that's kind of the conclusion you're making and you're trying to reach. So here are 3, and I've left the answer on there accidentally. Again, last thing I'm going to talk about for a few minutes. The first one, it's definitely got a negative correlation. I'm confident that correlation exists and it's there, but it's not strong. So I'm going to call it moderate. Here, this is a lot stronger. There's some real clarity that as I increase this increases and it's positive and it's linear. This one here, not really quite as strong as that. But again, I'm missing that patch in the corner and that patch in the corner. So it's negative and it's weak. And go from there. Next lesson, or maybe later this lesson, we'll talk about correlation coefficients. When we calculate correlation coefficients, so they're the R-squared values that you probably talked about before and used in different PSMTs over the last year and a half. When we calculate R-squared values, they give us a lot more of a definitive statement here. So you get an R-squared of 0.2, or we might call that weak. So you get that it becomes a bit more mathematical where we can say, here's the number, there's the conclusion, which is good with maths. Are there any questions on that? That's exercise 1D. And some of you who have moved across into this class may have already done it because we were working a touch behind. And if you have, great. It's a pretty easy exercise. You can go through and label whether it's linear, non-linear, whether it's weak, whether it's strong, whether it's moderate, whether there's no association, whether it's positive, whether it's negative. and go through some questions like that. You do have to draw some scatter plots as well. And at this stage of the game, I'll be expecting you to have done 1A, B, and C. So at some point, probably next week's double, I'll start checking homework as well, see that you've done it.